Okay. Hi, Irene.
Hi.
How are you?
Yeah, I'm good.
Yeah, I actually saw your message. You have asked for understanding more about the cardiac cycle graph, right?
Yeah.
You're a bit clear with the heart function and things, right? That's what you have mentioned.
Yep.
Okay. Okay, let me try to explain you with this graph, which usually we do, right? Yeah, I'm just going to. Can you see the screen?
Yeah, I can.
Yeah, okay. See, if you are very clear about the heart structure and the function, this is the very simple thing to understand about the cardiac cycle, okay? So you have to just remember the four important events that happens during the blood entry into the heart and the blood exit out from the heart. And as you know, the right side always contains the deoxygenated blood, right? And the left
Yeah.
side of atria and the ventricle will have the oxygenated blood. So the right side always has a simple function. Like it has to just get the deoxygenated blood from systemic circulation, then it has to send to the lungs for its, purification part, right? But the entire left side, what it is going to do, it is going to collect the oxygenated blood and circulate to every organ in the body. That's the reason, the ventricles on the left side has a very thicker walls too, correct? Because it has to contract and it has to give a pressure so that the blood flow is, the pressure of the blood flow is more so that it reaches all the organs, right? So this graph, you can see three important lines. The kind of yellow lines, what you are seeing here, the down ones, right? So that
Yeah.
represents the atrium, okay? And
Okay.
one represents the ventricle. Fine. And this graph usually shows only about the left side of the heart. We generally do not record anything about the right side heart, okay? So usually this is given for the left side heart. So now the green, you can see there is a race, and on top you can see a red color line, correct? That
Yeah.
represents the aorta's pressure. Okay, so what happens during one cardiac cycle is, here you can see this yellow and the green lines are almost same, right? Because that is the stage where the heart is relaxing. Okay, so if I say it is relaxing, it is a diastole. Okay, so what happens here? The atrium always receives the blood, right?
Yeah.
Through what valves?
Bicuspid and tricuspid valves.
No, actually, it receives through the vena cavas, the inlets. Okay, so the inlet of the heart does not have any valve. It is something like a automatic process that the blood keeps going inside the atrium. Only when the blood enters from the atrium to the ventricle, there is this AV valves. Okay, remember that is the tricuspid valve. So inside the atrium, there is a continuous blood flow. So atrium usually does not compress more or relax more. It is the ventricle that always compresses more and relaxes more. Fine, keep that in mind. So in the atrium, the blood flow starts and it slightly compresses and pushes the blood into the ventricles. Okay. So once the ventricle gets enough of blood, the pressure in the ventricle increases, right? So that time the blood from the ventricle should not get into the atrium. Back entry should not happen. So that is the moment the AV valves start closing. You got it? There, see, imagine there are two pots, one over the other. The topmost part just receives water without any particular valve controlling it. But then once there is enough blood, there is a pipe that opens into the second part. Okay? But the second part, when it overflows, it should not push back water into the first part. So it has to close that. So that is when the AV closes. Is it clear till now? So this closing of the valves is the lub sound. Is it clear? That records as a lub sound. So now
Yeah.
the ventricles, which has more of pressure, that is increasing, right? So it has to push the blood into the aorta. So slowly when the green curve goes up, you can see that red comes and crosses here, and there is an arrow stating that it is a semilunar valve. That is the valve that is between the ventricle and the aorta. Now this pressure makes the aorta walls open. So from the ventricle, blood starts flowing into the aorta. Okay. So at this point also, the ventricular pressure and the aorta wall pressure are equal. Okay. So till that time, this valve is closed. Now, because of the blood pressure that is increased inside the ventricles, the blood is pushed into the aorta until both the pressure comes to the same level. If you see, the curve comes down, and again at one point both the pressure is same. So that is the time the blood is enough entered into the aorta, the ventricular pressure is coming down. So now what will happen, ventricle pressure, when it starts deep coming down, the blood from aorta will again tend to come back into the ventricle, because pressure is more in aorta, less in ventricle now. To stop that, this semilunar valve closes there, so that whatever enters into the aorta, it will taken into the systemic circulation. Now ventricle pressure completely drops down. So what will happen, this atrium, there is always a flow, right? There is no control over it. So when this comes down, at the same time the AV valves open again, so that blood from the atrium again enters into the ventricles. Okay, so this valve closes when the ventrium is full. Okay, and the ventrium is empty, so the AV valves open back so that it can leave the atrial blood to enter into the ventricles. Are you able to understand? There
Yeah.
are 4 points, dear. The first one is AV valve is open, atrium to ventricle, the blood flow starts. When the ventrium fills, AV valve closes. So the ventricle now has enough blood, more pressure, so it opens the semilunar valve and pushes the blood into the aorta. And when the aorta and the ventricle has the same blood pressure, the atrium, the aorta should not push back the blood into the ventrium. So the valve closes. So ventrium's pressure comes down. Okay. So when the ventrium is free, now the atrium can push the blood back into the atrium. So the valve has to open. So this all lasts just for 0.8 seconds. Okay. So when there is a
Okay.
pressure here, it can increase only up to 120. The compression of the ventrium is too high. That is why the walls are thick and the atrium is completely slow. Okay. It is a very less pressure it has to apply to push the blood into the ventrium. Clear? That's why the graph doesn't go up for the atrium and then only increases when the ventricles compress. Okay. And then it comes to, there is actually a third sound which generally we don't consider. We always consider this lap and dub and the time between that, how much seconds it takes and what is the pressure your heart puts in pushing the blood into the aorta. Is it clear? So this is the one cardiac cycle.
Yeah. Okay.